Hi and welcome to Electrical Engineering Planet, and in this video I'm going to show you exactly how the thermocouple sensor works and what are the different types of structure for thermocouple. Also, the different types of thermocouple for different temperature ranges. Consider subscribing to Electrical Engineering Planet channel to support our community. Also, don't forget to share, like, and let knowledge enlighten your world. If we have a metal or alloy and we started to subject one end of this metal to a high temperature, and the other end will be in a room temperature. Now, the hot end electrons will gain high kinetic energy and diffuse away from the region of higher energy, the hot end, toward the region of lower energy, the cold end. Now, let's bring two different dissimilar metals or alloys and bond them together from one end and apply heat to this hot junction. And the other end will be subjected to room temperature, which we will call it the cold junction. When we measure the voltage across the two metals from the cold junction, we will find the voltage difference between them. Different metals have different rates of electrons diffusion, called the Seebeck coefficient. This small voltage that appears across the two metals is known as the Seebeck voltage, and it's the core principle behind every thermocouple. The greater the temperature difference between the hot and cold junctions, the greater the voltage produced. Although this voltage is very small, typically in millivolt range, but it can be precisely measured and correlated to temperature. To make practical use of this effect, engineers connect the thermocouple wires to a measuring device, such as a voltmeter or temperature transmitter. The device reads the tiny voltage and, using a calibration curve or lookup table specific to the thermocouple type, converts that voltage into an accurate temperature reading. Different combinations of metals produce different voltage-temperature relationship. For example, type K thermocouples are made of chromel and alumel alloys and are the most common for general industrial use. The temperature range now between negative 270 degrees Celsius up to 1370 degrees Celsius. For type E, we have a chromel and constantan. We have now the typical range is between negative 270 degrees Celsius up to 1000 degrees Celsius. Type J, made of iron and constantan, works well for lower temperatures, which use platinum alloys are suited for very high temperature applications, such as furnaces and glass manufacturing. To measure temperature accurately, we need to handle what's called the reference junction or the cold junction. In early laboratory setups, the cold junction was physically kept in the ice bath at 0 degrees Celsius because that temperature is stable and well known. In modern systems, however, it's not practical to maintain ice, so we use cold junction compensation. This means the instrument itself measures the ambient temperature at the terminals, usually using a small RTD sensor, and mathematically corrects the reading so the final output reflects the true temperature at the hot junction. Thermocouples can be built in several physical configurations depending on the environment. In an ungrounded type, the measuring junction is electrically isolated from the metal sheath, which prevents electrical interference. In a grounded type, the junction is welded to the sheath, giving a faster response time, ideal for measuring gases or liquids under pressure. And in an exposed junction, the wires are bare, giving the fastest responses of all, though they are less protected from corrosion or mechanical damage. Because they are simple and inexpensive and can withstand very high temperatures, thermocouples are used almost everywhere in power plants, refineries, chemical reactors, food processing, and even aircraft engines. In the next video, we will understand exactly the difference between RTD or resistance temperature detectors and thermocouples. Consider subscribing to Electrical Engineering Planet channel to support our community. Also, don't forget to share, like, and let knowledge enlighten your world. Thanks for watching.